Critical tasks are those we undertake where, if a failure were to occur, the outcome or severity could easily result in a significant injury or loss. When carrying out these critical tasks, it's essential we identify, manage and control all hazards and risks and focus on error traps and the error prevention tools to further mitigate risks. This enables tasks to be completed in a well-planned, safe and productive manner. Your supervisor will identify the activity as a critical task during the preparation and planning phase for the work. This is part of a mandatory process which must be followed, irrespective of the critical task to be undertaken. It's important you understand the process and your role within it, and this module is part of the Doosan-Babcock Critical Task Training for pressure testing. It will help reaffirm your personal awareness, accountability and ownership for these activities. Please take time to watch, listen and understand this module. It's important and it will be assessed. Pressure testing is a critical task under all circumstances. There are no exceptions. If you're pressure testing, you're carrying out a critical task activity. Before any critical task pressure test activity takes place, the test controller will appoint a competent person with the required competency, experience, technical knowledge and training to be in charge of the test. Note that the test controller and competent person could be the same person. The record of competency in pressure testing must be submitted to the nominated critical task authority, who will check the application and forward for inclusion on the register of personnel authorized for pressure testing. Test squad members will work under the supervision of the competent person and must have suitable trade and activity training and experience to undertake critical task pressure test activities. They are required to have read, understood, and signed the necessary documentation prior to commencing work. Before critical task pressure test activities, the pressure test procedural documentation must be completed, reviewed, and approved. This is mandatory and will validate the tests have been adequately engineered, risk assessed, and control measures implemented to ensure a safe test. The pressure testing procedure will include the following: details of test equipment, test medium, design temperature and pressure, test pressure, pressurization hold points, test duration and depressurization. Prior to work, all QA documentation must be completed, reviewed and approved. The nominated test area and competency of those involved must be checked and authorized. Pressure test parameters must be known and understood, barriers and signage in place, access, egress and emergency escape routes considered, and drainage taken into account should product be discharged. All pressure test equipment, including the test rig, must be thoroughly checked and a pre-test checklist completed. The competent person must carry out a Take 5 and ensure all members of the test squad fully understand the risk assessment and safe system of work procedures. When executing the pressure test, the following is required as a minimum. Equipment must be correctly assembled. Only authorized persons are allowed in the test area. The system must be filled, vented, and pressurized in accordance with the pressure test procedure. The pressure test must be witnessed and carried out with the required supporting QA, QC documentation. And once the pressure test is complete, depressurization must be carried out in a controlled manner and equipment dismantled appropriately. And once complete, a post-job brief must be completed. Critical task pressure testing activities have golden rules. No pressure test procedure, no pressure test. Any change or deviation, stop the test and reassess. Pneumatic testing is not permitted unless approved by a TA and branch engineering manager. The use of client test procedures is not permitted unless approved by a TA and branch engineering manager. There are no exceptions to these rules under any circumstances. Finally, prior to any critical task pressure test activity, a Take 5 must take place. No Take 5, no work. Those involved must sign to confirm they have read, understood and agreed to the method statement and risk assessment. As the tyres are the only part of the car in contact with the track, motor racing teams need to predict the exact amount of grip the tyres will deliver at every point in the race. Maintaining the optimum tyre pressure is pivotal, not just in optimising tyre and race performance, but in preventing an accident from occurring or something much worse. However, racing tyres are extremely sensitive to pressure fluctuations when inflated with compressed air. This is as a result of impurities, water saturation, and continuously changing water vapour and oxygen content as the race progresses. Reduction in tyre pressure not only affects grip and corner speed, but also significantly reduces the life of the tyre. For these reasons, motor racing teams often inflate their tyres with pure nitrogen. Nitrogen-filled tyres maintain race pressure much more reliably during the race, irrespective of the environmental and track conditions, tyre temperature and wear. The gas is delivered from pressurized gas cylinders, and the gas storage, pressure monitoring and gas delivery systems must be maintained meticulously to guarantee the purity of their contents. Two Doosan Babcock operatives were carrying out a routine pressure test in the vicinity of a boiler when a section of pipework burst, resulting in a release, covering them with water and debris at 800 psi. The operatives were experienced and competent. They were working to an approved test procedure, had created a permit under the client's safety permit to work, carried out a risk assessment, and highlighted a total of 13 separate control measures to mitigate identified risks. So what went wrong, and why were Doosan Babcock's expectations for this critical task pressure testing procedure not met? Of the 13 control measures identified in the risk assessment process, 8 were not followed, any of which would have prevented this serious or potentially fatal incident from occurring. The production of the permit was flawed. No mention of pressure testing was made in the permit. All tick boxes identifying hazards and control measures were ticked, which included the need for excavation, clearly not a requirement for this activity. The permit also stated that the system was free from fluid and depressurized, which it clearly wasn't. It was clear there was a complete lack of thought in the permit creation process, with boxes ticked with little consideration. The client-owned pressure test rig was in very poor condition and badly corroded. The operatives did not raise concerns when given the gauge equipment. The integrity and calibration of the device was not checked or confirmed. The rig only had a single gauge rated to 1500 psi when 2 calibrated gauges rated to 2070 psi should have been used. The gauges should have been checked, calibrated and in view throughout the test. During the critical task pressure test activity, the pressure should have been raised to half its maximum in 10% increments. The pressure was actually raised from 200 to 800 psi in one full increment over a 30-minute period. No close inspections should have taken place during the test, but inspection was carried out when the system was reading 800 psi. The persons carrying out the test should have been competent and authorized as appropriate. They were not. Supervisors should confirm competence of squad members by checking their records prior to any pressure test commencing. Risk assessment is the foundation on which a safe system of work rests, and if we don't follow the control measures identified in the risk assessment, we leave ourselves and others open to risk. In this instance, a serious or potentially fatal incident could have been avoided if the correct critical task process had been followed. Pressure testing is a critical task under all circumstances. There are no exceptions. If you're pressure testing, you're carrying out a critical task activity. And finally, remember that a Take 5 can be called to reassess the risk at any time during the task. If other hazards are identified, stop the job and reassess. If things change, stop the job and reassess. If you're unsure, stop the job and reassess. Thanks for watching.